In this video, let's solve little bit harder question about exact differential equation. First question, again, as we know, the coefficient of dx is m and the coefficient of dy is n. First of all, it must be, don't forget this, md in the form of n m dx and dy. So here the first things m and the second part is n. Let's solve. What's the condition? The derivative of m with respect to y must be equal derivative of n with respect to x. So derivative of m with respect to y, this is important because we will use the different type of derivative techniques. We know from calculus 1, but let's remind you, the derivative of x with respect to y, are there any y here? No, 0. But here we will take with respect to y, there is y and there is y here. So this is product, we must use product rule. Here there is term of y, there is term of y, that's why product rule. What the product rule says, we know that f times g derivative of first times second, and the first one times derivative of second. Derivative of first, derivative of y equal 1 times the second one directly, and the first one y times derivative of second one. Derivative of second one, derivative of exponential xy itself times, don't forget to take the derivative of power. Derivative of power with respect to y, xy with respect to y, derivative of y equal 1, x times 1 is x. So it will be yx exponential xy. So it's equal my equal exponential xy plus xy exponential xy. This is the derivative of m with respect to y. We took product rule for derivative, and be careful about the derivative of exponential. Don't forget, derivative of exponential, the same function times derivative of power, and the important which variable that you are taking with respect to. So derivative of n with respect to x. So 4 is constant, 0 with respect to x. There is x here, that's why again product rule. Derivative of first with respect to x, this is 1 times second, and the first one, that is x, times derivative of second itself. Yes, the same function. Now you will take derivative of power with respect to x. Derivative of power xy with respect to x, derivative of x is 1. 1 times x is 1 times y. Derivative of x 1. 1 times y equal y. So exponential xy, xy exponential xy. So you see they are same. It is exact differential equation. If you want to solve by using exact differential equation, you must show this condition. Without showing this condition, your solution will be contains missing part. That's why you cannot start directly solution. First, show the condition. So the integral of first part, x, y exponential xy. Let's take the integral. Here, the integral of x dx, the integral of y exponential xy dy. dx. So with respect to x, how we solve? This is easy, yes, but how we solve this one? Look, we will use substitution. Let's say xy is u. We are taking with respect to x, du equal with respect to x, the derivative of x equal 1 times y dx. So we will use substitution method for this part. Y dx, look, this integral. Y dx is du, exponential xy is u. So this integral, in fact, the integral of exponential u. What's the integral of exponential u? We know that integral of exponential u, again exponential u, exactly same. So the integral of x square over 2. The integral of exponential u, but write what is u xy. So exponential xy. We found the first integral. Why we are taking with respect to the x? Because the integral with respect to x. That is the derivative of power contains in the integral. That's why we use substitution. So the second integral, again, second integral 4 plus x exponential xy with respect to y. Again, separate 4 dy x exponential xy dy. Look, the same. The derivative of power with respect to y. X times 1x contains in the integral contains that part. That's why we can use substitution. Here u again xy du. Now we are taking with respect to y, x times derivative of y 1 x dy. We took with respect to y now. So here look, exponential u, because xy u, x dy du, the integral of exponential u, again exponential u. So this integral will be 4 constant 4 times y plus the integral of the second part exponential u. Instead of u, we know what is u, xy. We found the second integral. So what's the technique says? Write the first integral result. First integral here, first integral x square over 2 plus exponential xy. And as we write the second integral, ask yourself, did we use before 4y? Did we use before? No, we have to write exponential second part, exponential xy. Did we use before? Yes, we used exponential xy before. That's why cancel it, equals c. This is the result of first example. So in this integral, there are, as mathematics operation, two important parts: substitution for the integral and product rule for the derivative. And second, again, this is m, this is n. The derivative of m with respect to y. Are there any y here? No, the derivative 0. Here, what's the derivative of inverse tangent, arctangent? 1 over 1 plus y square. Maybe you learn what's the arctan x, 1 over 1 plus x square. Here the variable y, that's why I wrote like that. The derivative of n with respect to x, here denominator is constant and keep it because like product, and derivative of x with respect to x is 1 minus 2y, no x, 0, that's why it is 1. So they are equal. This is exact. Let's take integral separately. dx. So with respect to x, 2x to x square over 2 x square plus tangent inverse y. So we are taking with respect to x. There is no x here. So this is constant. Both the integral of constant itself times variable. That is x times tangent inverse y. And the second integral is important for us. X 2y 1 plus y square with respect to y. Let's separate it. It will be, look, we will write x over 1 plus y square minus, with respect to y, minus 2y over 1 plus y square dy. Two parts for the integral. The first part is easy because x is constant. We will take integral of 1 over 1 plus y square. What's the integral of 1 over 1 plus x square? Integral of 1 over 1 plus x square dx. We know that this is tangent inverse x plus c. So here in the same way with respect to y, it will be x is other variable, as product we keep it, tangent inverse y. This is important. So here 2y over 1 plus y square. Which integral that we have? Let's use substitution. I said lots of times, if you want, check the video for substitution method in the topics of integration, substitution, especially if you have a function and its derivative, you have to use substitution. So 1 plus y square, its derivative 2y, the integral contains 2y, that's why we can use substitution. 1 here, 1 plus y square equal u, its derivative 2y, dy equal du. So this integral will be 2y, look, 2y dy, 2y dy du, there is nothing, that's why 1 over 1 plus y square u. 1 over u du, 2y dy is du, 1 plus y square u. 1 over u, we know that 1 over u is ln u. The integral of 1 over x, ln x, the integral of 1 over u, ln u. So we calculate the integral here, ln u, but we know what is u. U is 1 plus y square. Okay, we calculate the second integral as well. By the way, normally you have to put absolute value here for the logarithmic function, because we know that the definition of logarithmic function says that the function that we have inside must be positive. But 1 is positive, y square is positive, not necessary to put absolute value. This is already positive. So we calculate the second. So let's write the result. What the technique says, write the first integral, x square plus x tangent inverse y. As we write the second integral, we will ask, did we use before? X tangent inverse y, did we use before? Yes, we used before. Cancel it. ln 1 plus y square, we didn't use before. ln 1 plus y square, and we finish. Nothing we have, so equalize to C. So in this video, we solved more difficult question about exact differential equation for integration and for the derivative. They are important as well. Now we are ready to solve all type exact differential equation.